Hello and welcome to this solution video of paper 52 A-level mathematics Cambridge International Examinations winter 2024. If you like this video, please give it a thumbs up yourself and share with your friends and subscribe to Math United. Let's get started with question number 1, which says at a college the students choose exactly one of tennis, hockey, or netball to play. That means no two games are selected by one person, so they are exclusive. The table shows the number of students in year 1 and 2 at the college playing each of these sports. One student is chosen at random from 120 students. Total, they are 120. Event X and N are these. Find X given N. So if you look at your formula table, you are given this formula. A given B. Probability is probability of A intersection B divided by probability of B. Whatever is given is denominator and their intersection is the numerator. And probability, not numbers. You can put numbers also, but we'll focus on probability. So question for us is X given N. So probability of X intersection N divided by probability of N. That's what we'll interpret this formula into this. Now, what is the probability that the student is year 1 and, because its intersection means he has to be the student playing football also. So not football, netball. So year 1 netball, 12 students out of total 120 are playing netball from year 1. That becomes our probability of student from year 1 playing netball out of all the students. Now probability of playing netball. Netball is being played by 40, right? 12 and from both the years 40 students are playing netball. What is the probability of selecting those students? 40 divided by 120. Since the denominator of both is 1, so same, so we can cancel it out. So we are left with the answer 12 out of 40, which is 3 out of 10. That's the answer of this one. So you could have directly do this also, but if you want to use this formula, this is how it is done. Now probability of N given X, the opposite of this, probability of N given X will be same probability of N intersection X divided by probability of X this time. So N intersection X we already got how much? 12 out of 120. Now X, not N. Probability of X means the student from year 1. So these three, they are the students from year 1. So that will be 16 plus 22 is 38 plus 12 is 50. So 50 out of 120, which was 40 out of 120 in previous one, and 120 cancels again. 12 out of 50, which is 6 over 25. That's the answer of B part. Let's look at the C part. Determine whether the X and N are independent events. The two events X and N are independent if the probability of X multiplied by probability of N is equal to probability of X intersection N. That means there is nothing common between them. That's why. So there is nothing which will be subtracted from this probability. That's why it is like this. So probability of X, we already have probability of X is 50 out of 120. Probability of N was 40 out of 120, and probability of X intersection N was 12 out of 120. Obviously this cannot be same, but let's cancel these zeros, and this will also cancel. So it will be 5 times 1, 5 out of 36. Yeah. And this will be nowhere near to 5 out of 36. I will not cancelling it. It is 1 over 10, by the way. 1 over 10 and 5 over 36 are not equal. We can say the events N and X are not independent. Moving on to the D part. D part says one of the students who plays netball takes a takes 8 shots at a goal. On each shot, the probability that she will succeed is this. The probability of success is given to us, which is how much? 0.15. So probability of success is 0.15. That means probability of failure, which is Q, will be 1 minus 0.15. That becomes 0.85. Independently of all other shots. So it is fulfilling all the boxes. It is ticking all the boxes for being eligible for binomial distribution of probability. Find the probability that she succeeds in on fewer than 3. Fewer than 3 means 0, 1 and 2. They are fewer than 3 of these shots. So there are total 8. So we'll find probability for each one in binomial probability. So it will be the general formula for that is NCR, probability of success to the power R, probability of failure to the power N minus R. That's what we'll do for 0, 1 and 2. So first will be, our answer will be probability of 0, means none of those shots are successful. So it will be 8C0 p to the power 0, not p, let's write 0.15 to the power 0 and 0.85 to the power, all 8s are failures. Then what is the probability of one success? 8C1, which will be any one of those 8 shots, power 1, and this will become 0.85 to the power 7. Then probability of 2 of the 8 shots being successful, 8C2, 0.15 to the power 2 and 0.85 to the power 6. Let's evaluate them separately and add, because either this will happen or this will happen or this will happen. When we say or, the probabilities add up. So whatever I get here, I will add up those probabilities. By the time I calculate those probabilities, I would request you to like this video, share with your friends and subscribe to Math United. So what I'm getting here is 0.2725 in 4 digits after decimal, here 0.3847 and 0.2376. If I add them, it comes out to be 0.8948, quite a high probability. Question 2. Find the number of different arrangements of 9 letters of the word algebraic. Okay. So there are how many? 9. So 9 factorial ways they can be rearranged. But since A is repeating here and here, right? A is coming twice. We'll divide it by 2 factorial, because whatever place they take it in place of each other, that will not be counted. That's why we divide by 2 factorial. And there is no other letter that is being repeated. So it will be 1814440. That many arrangements. Question number 2. Find the number of different arrangements of 9 letters of algebraic same in which there are no more than 2 letters between the 2 A's. So 2 A's are there. There could be possibility of 7 other letters in between them, but they're saying no more than 2. No more than 2. That means there can be 1 or 2 and can be 0 also. No more than 2, because sometimes this language confuses. I would say that if there is nothing in between them, they are together. That is also a case. And 1 and 2 possible between them. So that's what I'll say. So let's focus on the one with no letters between them. So what will I do? I'll make a box around them. That means they are always together. There's nothing in between them. And there are how many? 7 more. 1, 2, 3, 4, 5, 6, 7 more. So that means this one box can take, or these 7, or this place is already taking, so it can take 8 factorial ways, right? 8 factorial ways it can be arranged. So the answer is 8 factorial for when 0 alphabets between A's. Now this is the case number 1. Case number 2 is when 2 alphabets are between, not 2, let's start with 1 alphabet between them, right? So that means there will be A, then there will be some alphabet between them, then A, right? So, and then there will be 6 more spaces, 3, 4, 5, 6, yeah, 7. So these two A's can take these two places, or they can take A and A. This is the second case. That means this A will go here, and this way A will go here, right? So this way, how many ways they can change their places? So there are already 2. One was here, one was here, and let's say when it goes till here, we'll count this: 3, 4, 5, 6, 7. So there will be 7 cases of what I'm doing here. So 7 cases, and then these A's, if they change places with each other, doesn't matter. So we will not count it, just like we did not count this box's places inside. So only thing remaining is the remaining 7 places. They will take each other's place. They can take, right? In every of these 7 cases, they can take each other's place. So this will be 1, okay, whatever that is. And third case will be when, let's do it here, when there are 2 alphabets between A's. Okay. So A, 1, 2, A. 2 alphabets in between A's, others are here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So now I will see, like I looked here, where can this second A can go. It went 7 places. So this can go, it's already 1 place here, 2, 3, 4, 5, 6. And accordingly, this A will also move those 6 places, right? So 6 multiplied by, and these are how many? Remaining 7 places. 7 ones, so 7 factorial. This can be the possibilities. So we got these 3. We have to add these and put in our calculators. So I'll put this plus this plus this. I'm not finding them individually. I will find them separately and do it. So by the time I calculate them, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 105,840 arrangements. Question number 3. A fair coin and an ordinary fair 6-sided dice, both are fair, so that is good, are thrown at the same time. The random variable x is defined as, if the coin shows a tail, x is twice the score on the dice. If coin shows a head, x is the score on the dice if the score is even, and x is 0 otherwise. For odd, that means this is 0 for odds. That's what they're saying. Alright. Draw up a probability table for the table for x. Okay. So first, what are the possibilities in this if it is a tail? So let's say it gives tail and head, and it is fair, so probability is half and half. So what are the probabilities here? There are 6 probabilities, right? 6 probabilities. If it is 1, we get a score of 2. If we get 2, we get a score of 4, 6, 8, 10, and 12. These are the possibilities with a tail, because x is twice the score on the dice. So all of the outcomes are doubled. All right. And they all have probability 1/6, 1/6, 1/6, 1/6. Okay. Now, when head comes, again, there are 6 possibilities, right? So if 1 comes 0, 3 comes 0, 5 comes 0. When 2 comes, when it is even, it is the same score. It is the score on the dice if the score is even, the same dice. So 2, 4, 6 will give you 2, 4, 6. Right? So now we can make a distribution table. So first we draw a table like this. We write x here, then probability of x equal to x. Okay, so what are the outcomes? We know from the tree diagram here now. First we'll have a 0. Then there is no odd here, there is no odd here, so we have straight away 2, 4, 6, 8, 10 and 12. So now let's see what are the probabilities individually. First for 0. First we'll get an head for that, so that means half. Multiplied by, we have 3 out of 6. That means half again. This is the probability of having a 0. Right? Now, for 2, we'll get half and then 1/6. Yes? Probability of this 2 is 1/6 out of all of them. Or, we can get a tail and we're getting a 2 here again, 1/6. So that becomes 1/12 plus 1/12, which is 1/6. Okay? Now, let's go to 4. There is 4 here, which is again same 1/2 times 1/6 plus 1/2, same, exactly same. 1/6, because there's only one branch which is having 4 here, so 1/6. Same for 6. But the story will change for 8, 10 and 12 because there are no 8 and 12 here. So they will be just half times 1/6. That's it. Half and 1/6 for 8, 1/6 for this, 1/6 for that. So that is 1/12. So 1/12, 1/12 and 1/12. To test whether your calculations are correct, add all of them. That should be equal to 1. So 1/4 plus 1/6 plus 1/6 plus 1/6, all of them should be equal to 1. Just, I'm sure they are 1, right? But you can also check them by adding. In your exam scenario, always check before proceeding. Otherwise, your next table or next answer could be wrong. So like this, we have to find variance for the same. It could be wrong if these entries are not right. Okay. So draw up the probability distribution table. We have done that. Now we'll find the variance, which is part B. Okay. For variance, we should know the formula first. Variance x is equal to sigma x square multiplied by x means capital X, okay, multiplied by its own probability divided by sigma p, right? But we know that the sigma of all of the probabilities is 1, so there is no need to write the denominator, right? Minus, it will be the square of the expected value of x, and for expected value we write sigma x and px, no square in this one. This is what we will have to calculate to find the variance. Okay, so let's do one by one. Sigma means add all of them. So I'm getting 0 square multiplied by 1/4. So let me write for the sake of writing it, otherwise there is no point in writing a 0. So x squared and its probability multiplied with it plus and just we have to do this. I will do it manually once to some certain stage, and then after that I will use calculator. You can straight away put this in a calculator if you are so confident that your entries will not have any problems. So this is 0. This will be 2/3. Okay. This will be 16/6, which is 8/3. 36/6, which is 36/6. 6. 64/12 to 16/3 plus 100/12 plus 144 over 12 minus 0 plus 1/3 plus what I'm getting with my calculator is 59 over 4 or 14.75. This is the variance of x. Question number 5 is based on normally distributed data. So I'm ready with the table here. It says the heights in meters of white pine trees are normally distributed. Okay. With mean 19.8 and standard deviation 2.4. So let me try to visualize this. If this is the line and this is the normal distribution, the mean is 19.8 and standard deviation is 2.4. Okay. In a certain forest, there are 450 white pine trees. 450. Okay. How many of these trees would you expect? That means we have to find expected probability first, and then we'll find. So expected value of x is equal to np. So we need to find probability. To have a height less than 18.2. So suppose 18.2 is here. We have to find how many of the trees out of 450 are into this. So we'll find probability first. And for probability, we have to find z-scores. So z-score that the height, let's call it x, is less than 18.2 meters, right? For that, z-score will be the 18.2, whatever is x, minus mean, which is 19.8 divided by standard deviation, which is 2.4. This is how we find how many standard deviations it is away from the mean. That's what it means. So it will be minus 1.6 over 2.4, which is 2/3. 2/3. So 2/3 is minus 0.6666, or we can write it 7. This is the z-score, but it is negative, right? So what will we do? We'll do the opposite of what is being seen here. So we'll find the probability of what is, because this table I'm referring to, I prefer a table because it gives us exact value we want. In calculator, sometimes we may enter or make mistakes in entering numbers, so we can get wrong ones. So I'm using this table. So what will I do? Minus 0.667, this will be plus 0.6667, right? The reflection of this here. This table will give me the probability which is less than this. If I will subtract this probability from 1, I'll get the one which is more than positive 0.667, this probability, which will be exactly what I want on the lower side, because normally distribution table or graph, they are uniform. So this is what I'm going to do now. So I'll use positive 0.667, not the negative one. 0.6667. So 0.66 is 7454. 0.66 and 67. So I can do this one. 7 is here, right? 0.6. No, it's 23. So 23 will be added to 7454. 7454. 7454 and 23, right? Let's see, 23 will be added to this. So it is 0.7477. 7477. 0.7477 is the probability of z being less than positive 0.667. But our target was to find this so that we can reflect it and make it equal to this one. So probability of Z being greater than 0.667, 3 digits, right? We got 3 digit only, so 667 will be same as probability of Z being less than minus 0.667. They are the exactly same thing, right? This and this will have greater than this or less than this are the same thing. So that is 1 minus, we are subtracting, the previous one we got 0.7477, and which will be 3, 2, 5 to 0.2523, and we can round it off to 0.252. That is the probability that that the pine tree is less than 18.2 meters tall. Now we have to find the probability, and not probability, expected value. So expected value of x being, let's write clearly here, x being less than 18.2 meters will be n. There are 450 of them. Multiply by this probability, which is 0.252 we got, and we'll find how many of those trees are like that. So 113.4 what I'm getting, so I'll write 113 trees only. 113 trees. Let's move on to the second part of this question, which is that the heights in meters of red pine trees are normally distributed. So red pine trees, and they were white pine trees. Okay, so there is a difference. This is a second part of the question, so it has nothing to do with the previous one. Normally distributed with a mean of, let's say, mean of 23.4. Okay, taller, and standard deviation sigma we don't know. It is known that 26%, so the probability is already given to us. 26% of the red pine trees have height greater than 25.5. So let's say 25.5 is here. So this probability greater than 25.5 is 0.26. Yeah, 26% is 0.26. Find. So we'll go reverse here in this case. So probability that x is greater than 25.5 is 0.26, which if I convert it to z score, so I should convert it to z score also. Z score of 25. So x is less than, right? Less than, I will write 25.5, because our table is again for less than, not greater than, will be so probability of x being less than 25.5, let's convert that first, will be 1 minus 0.26, which is 0.74. So we'll find the z score, which is corresponding to 0.74 probability. Okay, so that we have to find, write it here. So the probability is given now, not the z score, but the probability is given 0.74. 0.74 is here. 0.7389 is 0.64. Let me write somewhere 0.64, and we need 11 more to make it 7400, right? 11 will get between 10 and 13, which is 3 and 4. Let's say 35 here. Yeah. So we are getting 0.6435. That's what we'll get. Okay. So we'll use 0.6435 in our question now. Is Z score is 0.6435. So for the probability 0.74, this is Z score, and Z score is always the X value, which is 25.5 in this case, minus mean 23.4, divided by the standard deviation, which is unknown to us. So we'll do the cross multiplication now. So the sigma goes there and it comes here. So sigma will be equal to 25 0.5 minus 23.4 divided by 0.6435. Let me use my calculator for the same. And by the time I do this, I will request you to like this video yourself by clicking on that thumb up icon. Share this video with your friends. I think this is the first video worldwide without a marking scheme, which is being solved by me. And if you appreciate that, like this video and share with your friends. Subscribe to Math United. What I'm getting here is 3.2659 something. So I will write it about 3.27 meters. That's the standard deviation. Question 5. It says in a class of 21 students, there are 10 violinists, 6 guitarists and 5 pianists. Okay. A group of 7 is to be chosen out of those 21. 16 plus 5, 21. Okay. The group will consist 4 violinists, 2 guitarists and 1 pianist. So 4 plus 2 plus 1, 7. Okay. So this is a very straightforward question. 4 violinists are to be chosen from 10. So it will become 10 C4 and 2 from 6 guitarists C2 and then 1 out of 5. Just because they are mutually exclusive, the choice is totally different, so they will be multiplied. And in how many ways it will be done? This ways. So just put this in your calculator and you'll get it. What I'm getting is 15,750 ways. Let's go to the second one, which says on another occasion, a group of 5 will be chosen from 21, not 7, now 5. The group must have at least 2 violinists. So let me write violinist, guitarist and pianist. At least 2 of them. So we'll start with the at least. 1 guitarist and at most 1 pianist. So it is not 5 yet. That means we will have to put a 2 here. So it becomes at least 1 guitarist, at least 2 and 1 pianist. Okay, so again we'll put here, we'll increase this one to 3. Are there 3 guitarists possible? Yeah, there are 6 of them, so 3 is possible. And no pianist, because they said at most 1 pianist. So we can have 0 also. So can we have 2 and 4? No, we can't have 2 and 4. So, and we can have 1 also, but then in that case we should have 3, 1 and 1. So we increase violinist to 3, reduce guitarist to 1 and 1 pianist will be there. Again we will increase the guitarist to 2. So 3, 2 and 0. Right? Okay. And we'll have to go to 4 then. 4 violinists. We have 4 and yes, we have 10 of them. So 4 is possible. 1 guitarist and none of them. So 4 plus 1, 5. We can't have one of this, otherwise it will become 6. So 1, 2, 3, 5 possibilities are there. We'll interpret them into the possible arrangements. I'll do one of them and then I will fasten up this video and give you the answer. So in first line, 2 violinists are being chosen from 10. So it will become 10 C2. Then we have 6 guitarists and 5 pianists. So I have written them and calculated as well. I did not write anything for zeros because anything C0 is 1. So there is no point of writing it. So I have not written it. These are their values individually. And if I add all the combinations, what I'm getting is 10935 combinations. Question number 6. Teams of 15 runners took part in a charity run last Saturday. The times taken in minutes is given by this table. Okay. Draw a back-to-back stem and leaf diagram. It is worth 4 marks. Wow. To represent this information with falcons on the left. So let me draw a line. Okay. Falcons have to be on left. So falcons will be here. And that means the kites will be on the right side. They are in increasing orders. Yes, they are in increasing order. Nothing challenging here. I don't know why. 4 marks for this. But anyways, so the first digit is 3 here. Then we have 4, 5, 6 and 7. I will just fasten off this video also. And I'll finish and explain to you what happened. So I have drawn the stem and leaf diagram, and I will write key here. Always write a key. So if I write 4 this way and say 4 here, not 4, let's say 6 and 7 here, represents 46 for falcon, yeah, and 47 for kites. This is the key which should be explained. Alright, so I wrote the first digit here, and can you see the smaller digit on the right side, higher digit on the left side. Don't write 8, 9 in this one. That will not be wrong technically, but it's better to write this way. Okay, what is this B part saying? Find the median and interquartile range of the times of falcons only. Do we have a third part also? Yes, we have. Okay, so for falcons we have to find median and interquartile range. Okay, so median first. Let's call it Q2, right? Then we'll find Q1 and Q3 also. Okay, so first we'll find median, which will be the middle of these. How many are they? 15. So what will be the position of the median? 15 plus 1 divided by 2, which is 8th. 8th position from back or front. 8th position will be the median. So I'll start with this one. 1, 2. Again, because this small number is here, third will be here, not here. 3, 4, 5, 6, 7, 8. This becomes median, which is 51. Now we'll find the median of the lower numbers, and 1 will not be part of it. What will be the median of them? That will be our Q1. So how many are they? 1, 2, 3, 4, 5, 6, 7. So 7 plus 1 divided by 2, which is 4th. 4th number in both the halves will be our Q1 and Q3. So first Q1. 1, 2, 3, 4. 44 is Q1. Q3 will be 1, 2, 3, 4. So 9. 59 is Q3. So they said find median. We have found it. So median is Q2, which is 51. Interquartile range is 50 Q3 minus Q1, which is 15. 15 and minutes, right? Minutes. That is the IQR. Alright, the next one. Let X and Y denotes the times in minutes of a runner from falcons and a runner from kites respectively. Understood? Sigma X, they have already added it, 792. So they have not let us to do it. They have saved our time by doing this. Sigma X is given to us. Sigma X square is also given to sigma Y is given. Sigma Y square is given to us, all of them. The mean and standard deviation of the times taken by all 30 runners from the two teams. You have to find the mean. Let's find the mean first. So let's find the mean, not X. We'll write straight away mean. Since we are finding the mean of two quantities, so we should have the sum of X and Y divided by how many they are. So sum of x data is already given to us. So sigma x plus sigma y basically divided by n will be our combined mean. Okay, and let's call it m. So sigma x is how much? 792 plus 783 is sigma y divided by, they are 15 plus 15, 30. So it will be 2 plus 3, 5, 17, 1, 15, 75 over 30. Let's convert into decimals. So it will be 15.5 minutes. Now we have to find the standard deviation. Standard deviation of this will be square root of x square sigma x square plus sigma y square over n minus mean square, which is 52.5 square. This is the formula for standard deviation, which will be square root, and we know sigma x square is 43504 plus 42,223 divided by 30 minus 52.5 square. Just put this in a calculator and you'll get the standard deviation as well. By the time I do this, I would request you to like this video by clicking on that thumbs up icon and share this video with your friends. I think I'm the first person in worldwide to answer this paper without a marking scheme. And subscribe to Math United, please. What I'm getting here is 10.065, so I will write 10.1. 3 significant figures. 10.1 minutes is the standard deviation of this data. Question number 7. In a game, players attempt to score a goal by kicking a ball into a net. The probability that Leno scores a goal is 0.4. So his probability of his success is 0.4. That means the probability of his failure will be 1 minus 0.4, which will be 0.6. Okay. On any attempt, independent. The random variable x denotes the number of attempts that it takes Leno to score a goal. So here probability of x equal to 5, that's what they're asking us to find out, which means that he is successful in 5th attempt. That means he has 4 failures before the 5th attempt is a success. That's what they're asking us to calculate. So that's what we will do. We will do what? 4 failures first. The probability of x equal to 5 will be 4 failures, which is 0.6 4 times. So power 4 multiplied by the success the 5th time. This will be his probability, and which comes out to be 0.05184, and we can ignore that for 3 significant figures. This will be the answer of A part. What about B part? Find that the success is between 3 and 7th attempt, both included. 3 and 7 both included. So let's say that he is successful on 3rd attempt, or 4th, or 5th, or 6th, or 7th. Yeah, everyone will have different probability, because it's a geometric probability distribution. So we'll have to see, there is no straight away method of finding them. So let's say 3rd attempt, which means Leno fails in 2 attempts and is successful in the 3rd attempt. Similarly here, he fails in 3 attempts and is successful in 4th attempt, and similarly I will write for others also. So what I can do, if I have to add them, I will take 0.4 and 0.6 square common if I want to add them, because if it will happen either this or this or this or this. So I have to add all these probabilities. So I'll take 0.6 square times 0.4 as common. This will be taken as common, and I will just add more. So because the whole of it is been taken common, so I'll write 1 for this. For this we have 0.6 extra, so I'll write 0.6 here. Then I will write 0.6 square for the fifth attempt, then 0.6 cube and 0.6 to the power 4. Just put this in a calculator and you'll get your answer. What I'm getting is 0.3320064, so I'll write 0.332 to the nearest 3 significant figures. Part C says find the probability that Lino scores his second goal on or before fifth attempt. On or before fifth attempt. So this will be a little different, where we can see that he gets a second goal in second attempt. First one also a successful attempt and second one is also a successful attempt. So that it becomes that his second successful attempt was in second attempt itself. So second will be 0.4 square, because first is a success, second is also a success. So that will be, he gets success in second time in third attempt. That means out of the first 2 attempts he gets 1 success, right? And that will be 0.4 multiplied by 0.6. So 1 success, 1 failure in first 2 attempts, and then third he gets a success again, right? Now fourth, out of the previous 3 attempts he gets success in one of them, which is 0.4 probability, and failure in 2 of them. Which 2 we don't know, but this is how we can do. And then in fourth attempt he gets the success. Now fifth attempt he gets second success. So that means previous 4 attempts he gets just 1 success. Then he fails in 3 out of those 4 attempts, and then the 5th attempt is a success. And now I need to add all of these 2, and you can see that all of them have 0.4 square common. Yeah? So I will take 0.4 square common. First, when he's getting success in second attempt is just 1, because 0.4 square whole is taken common. Here this and this are common, so let's this 0.6 and 2, 2c1 is 2, okay? So 2 times 0.6 is from here, then 3c1 is 3 times these 2 are already common, so 0.6 square, and then 4c1 is 4 multiplied by 0.6 cube, and this should give you your answer. And I will also try it. By the time I do this, I will request you to like this video. If you really did, give it a big thumbs up, share this with your friends, and subscribe to Math United, because I think worldwide this is the first video without a marking scheme, and you will get to know how to approach questions in detail. Thank you very much. Let's write my answer. It is 0.66304, so 0.663 I will write. That is the nearest 3 significant figures. Okay. Last part of this last question is this. Lino has 75 attempts to score a goal. 75 is a big number. That's why we need a suitable approximation. And we know only one approximation in A level, which is normal approximation. For normal approximation, you have to test first that NP has to be greater than 5 and NQ is greater than 5. It's just a formality because we don't know any other approximation, but still we should test it first. So n in this case is 75. Probability of success is 0.4, it was given, right, for Lino. 0.4, which is 30. Yeah, 30. So yeah, it is more than 5. 30 is okay, done. Similarly, 75 times 0.6, obviously it is more than 30 because the number has increased, and which is how much? 45. So more than 5. Done. Testing is done. Now we need to draw the approximation here. So for this approximation we need a mean, and that mean is 30 for s, because mean is n times p, which we did just here. 30 is your mean. We need a standard deviation also, which is square root npq. So we'll find this, which is n is 75, p is 0.4, and probability of failure is 0.6. What I'm getting is 30. Okay, 3 square root 2 as the standard deviation. All right, so we have standard deviation, we have mean, and now they're saying find the probability that Lino scores more than 28, because it's an approximation. So 28 will be somewhere here, but we will not take 28 because they said more than, not equal to, more than. So we will start with 28.5 because it's a discrete data. So we will take the one between integers, 28.5, and fewer than 35. That is 35 is also not included. That means our this limit will be 34.5. So neither 28 nor 35 included. We'll have to find this probability. So what will be my plan to find this probability? I'll first find the probability of less than 28.5. Then I will find the probability of having it less than 34.5, this whole of it, which includes the previous one. Then I will subtract the probability of less than 28.5 from less than 34.5, and we'll get the remaining, this middle one. So from this probability, I will subtract this probability, so I will get the probability I want, right? So let's focus on 28.5 first, and I'll have to draw it here separately so that there's no confusion. So this is 30, this is 28.5, and I need to find this probability, right? For this probability, I need to know z score. X is less than 28.5, and this will be 28.5, which is x minus 30 divided by the standard deviation 3 square root 2. After putting this in my calculator, I'm getting minus 0.3535. There are more digits after this, so I'll write it minus 0.354. However, there is no negative z score in this table I have here. So what will I do? I will find the opposite of it. That means I will find the positive one, positive z score of 0.354 here, which will give me this lower probability. I'll subtract it from 1, so I'll get higher probability, which will be exactly what I want, this one. So if we don't have here, no worries, we can do this way. So I'll ignore negative. I'll just put 0.354. I'll look for here. 0.3 is here. 5, 0.6368. And then we have 4. So 4 is 15. So 1 5 will add to the last two digits. Becomes 0.6383. This is the probability of less than this one. So we want to find greater than. We subtract it from 1. 1.0000 minus 0.6383. That comes out to be 0.3617. Okay. 0.3617 is the probability we were looking for, this one. 0.3617. Now we have to find the probability less than 34.5. and I'll do that here. Same 30, but now it will be 34.5, and it is on the positive side, so we don't have to do all this stuff in this case. So first, z score of x is less than 34.5 is 34.5 minus 30 divided by 3 square root 2. So it will be 4.5, which was minus 1.5. So 3 times this. 3 times this will be 1.0609. Okay, let's say 1.061. Okay, 1.061 is the z score for 34.5, and less than that, this is what probability we want, and table will give us that probability only. 1.061. 1.06. I can't see it. Okay, 1.06 is this. 8554 and 1 is 2. So 8556. Probability that x is less than 34.5 is 0.8556. So we got two probabilities we wanted, this and what was the previous one? 354. That was the probability. No, that was z score. 3617. This one was the probability, right? So the probability that your x lies between 28.5 and 34.5 is 0.8556 minus 0.3617 is 93940. 0.4939, and which can be rounded off to 0.494. This is the probability of whatever they were asking. They were asking that Lino scores 28 goals, more than 28 goals, but fewer than 35 goals. This concludes our solution video for paper 52, Winter 2024 A-Level Mathematics. I hope you liked it. If you really did, please give it a big thumbs up and subscribe to Math United. Thank you very much for your attention.